So this is an integral we need to compute. This is the function. It's honestly an unpleasant function to deal with, as it seems. You know, tangent and then x and then e to the x minus e to the minus x divided by 2. Like, I don't even want to start writing this down. And there won't be a need for me to do so, because we only need to make a very nice observation. So usually there are very difficult integrals which just evaluate very simply. And I think this is one of them. First thing I want you to notice is that this interval is symmetric. Then I can probably write this as -1 to 0 f of x dx plus integral from 0 to 1 of the same thing. And then I want to make a certain specific claim about this function. So my claim is that this integral will be 0. More specifically, my claim is that f of x is equal to f of minus x is equal to minus f of x. Focus on the minus sign. So I can take the minus sign outside, basically, is what I'm saying. Let's test this. So f of minus x would be plugging in minus x for x. So don't get lost here. That was very smooth. I'm looking for minus x. I'll remove all of my x's and I put minus x's minus x and then minus of minus x and then tangent of minus x. Okay. Then this is not too bad. You know, we can simplify this. Then if I simplify this, I'll get minus x is on the outside. Minus of minus x is just x, right? And then tangent of minus x. So the tangent of minus x is also the tangent of x. Perhaps this needs an argument. Okay, maybe I'll just list it as a fact for now, and then we'll worry about it in a moment. So for now, just believe me. For the other terms, we'll see what happens now. So we have minus x here. We have e to the minus x minus e to the x. We claim that this is just the minus of yes. We claim that this is the minus of f of x. And there's a minus here. So maybe if I can just remove the minus and I can put this instead of that. So it's like I switch the sign for each term. I can just switch them around. So this looks like f of x. Which says that there's probably a mistake. Now my confirmation bias, because I know that this should be true, I know that this is now a mistake. So this is not precise, but what is precise is to say that the tangent of minus x is the minus of tangent of x. And if you say this, then here you get a minus of tangent of x. And if you do this, then you get a minus f of x. So this probably still needs some convincing, but just believe me for now. And if this is true, so if this is true, I just get the exact same expression for f of x, but there's an extra minus. So that's where it's coming from. So I'm done with the proof. That's good. How does this help me compute this integral? Here's how. The integral is symmetric. So an integral from 0 to 1, f of x, from minus 1 to 0 of f of x, is equal to the integral from 0 to minus 1, but with the negative sign taken. So I can switch the signs, because in the end, when I evaluate f, let's say I get big F, and I need to evaluate it from, let's say, 0 to minus 1. This is usually f of minus 1 minus f of 0. If you switch it around, it's the minus of this thing, more or less. So that's why it gets shifted in some sense. I'm assuming that this is the integral of the function if it exists. Now this is being hand waved, of course, because it's not a core focus for the tutorial, but it is a true statement. And so if this is true, then it is very convenient, because what we have here is minus of f of x. And minus of f of x is equal to f of minus x. So minus of f of x is equal to f of minus x. Maybe I'll call this claim, I'll give it a star, and here I use my star. F of minus x equals minus f of x equals f of minus x. So this is f of minus x from x is equal to 0 to x is equal to minus 1. And notice this is going to be magical right now. It's just going to work like magic. So x is equal to 0 to x is equal to minus 1. We're taking f of minus x. Well, logically, that's the same thing as taking f of x as well. But you take it from 0 to 1. Now, why is this true? Why is this true? Why can't I just write 0 to 1? Because all the values from x is equal to 0 to x is equal to minus 1 are negative. But then I'm multiplying them by minus when I plug them in. Then all of my values become positive. You see what happens? So that's really what happens. And guess what? if this is true and these two terms are exactly the same, then the value for the integral is 0. Now, what I just did, by the way, so this is the definition of what is called an odd function. This is the definition of saying that f of x is odd. And that's really just the definition of it. And so odd functions in general, if you integrate them over a symmetric interval, so let's say from -5 to 5 or from -n to n, then usually the integral is equal to 0. And you will face many very difficult integrals which are actually not that difficult because let's say the function is odd, and then if the function is odd, then the answer is 0. And now this perhaps requires a bit of convincing. So if you are interested, maybe just give me a moment and I'll look into it. So I've looked into this and it's actually not that difficult to see. So this is actually true because if you look at the definition of the tangent function, it's the sine of minus x divided by the cosine of minus x. And the reality here is that cosine of minus x is even, and sine of minus x is odd. We get something that looks like this. And then if this is true, then clearly the statement is true. And that is how we conclude. So to recap, if you have an odd function that's complicated, then it is always 0. But the trick is to ask yourself the right question. If you see a symmetric interval, then this should always ring a bell. And the bell is to check if the function is odd or not, because if it is, it will save you a lot of time. By the way, whenever you see an odd function, you don't need to provide this full argument. What I just did is I tried to make sense why an odd function should be equal to 0, but you should not. Now that you know how it's like, then you do not need to argue for this. You can just say, hey, this function is odd. If this function is odd, then the integral is 0, and then you're done.